The definition of digital twin, I would say, is still an evolving definition. It is a digital replication of a physical asset. Most of the time, we're going to be talking about that in terms of a building when we're talking digital twin. The key part that makes a digital twin different from, we'll say, BIM or a Revit model is that a digital twin needs to be a little bit more alive. It needs to be current to the status of your physical building, your physical asset out in the field. Whereas BIM is a snapshot in time, digital twin needs to take that information. It can be 2D information, it can be 3D information, graphic, non-graphic data, all these things building into it, but it needs to reflect the current state of your building. Here's the big question. Getting to the current state of the building in your digital twin requires a few different things. It does require good drawings, good modeling information, so you've got a representation of the geometry that you have for the building, but then you also need to bring in sensors. That brings back the IoT, Internet of Things type of idea, where we're going through and we've got sensors of the building that are detecting occupancy, detecting temperature, detecting whatever it is that matters to you in that particular facility, and have a way to take data from that sensor and transmit it into a place, a location, a data lake, whatever the term is that you need to have it be, that can feed the digital twin. If you're thinking about things from, say, the point of a nuclear agency, you might really be worried about temperature checks or just different things related to radiation. Most people don't have to worry about radiation, but if you're going into then maybe, say, the idea of a hospital, you might really care about things like a location center on medical carts, so that you know where in this massive facility is that cart that has that piece of equipment that you really care about for things that are mobile. In a school, you may not care about the mobile cart that is there, but you do care about occupancy. Where are all of these kids that we're supposed to be tracking and managing and loving on in our school? So it very much is going to be dependent on the individual use case scenarios, and people are going to come up with amazing creative uses for a digital twin that we're not even thinking about now, just because that's who we are as a creative society. The benefit of digital twin just comes back to knowing what's the reality of my facility. The classic thing when we're talking about the cost of a building, you get some 10% plus or minus that goes into the initial design and construction of the building, and then your other 90%, 80%, whatever number you want to choose, the vast majority of your investment is managing that building over the rest of its life. So anything we can do from a digital twin standpoint that will help us with managing proactively and reactively that facility, that's where digital twin comes into play, whether we're talking about a building for its various heating and cooling or fluid transfer, hot, cold water, or medical gases, whatever, making sure that those are running smoothly, efficiently, and if something's got a little bit of a hiccup, knowing when that hiccup starts early on instead of reacting after something's fully broken. Where it can help with collaboration is, we'll say, on the facilities management end of things, where you'll have building engineers, different HR groups, different people working within a building. If they can understand the reality of your building and the trends within your building, because ideally, if you've got a digital twin that's telling you what's happening right now, you're storing that information. So not only do you know what happened now, you know what happened last week and the week before and last year. And so we'll build up these good data sets of how the building is being used. And you can use that as aiding collaborative efforts of the people that use the building to be more efficient in how they're using the building. Are we using all of the right spaces at the right times, or are there better ways that we can make use of this facility based off of us knowing certain rooms get overused, certain rooms get underused? How can we balance that out and collaborate together in how we're managing that facility? When we're talking about digital twins with sustainability, the biggest piece in that, in my view of things, is how we can take building performance and the reality of building performance into engineering and design decisions as we're saying, does the roof need to be re-insulated because we found that certain areas are a little bit more leaky? Something sagged in the walls and we need to puff up something in different ways that we weren't necessarily thinking. It's just, it's a cold spot. Well, let's actually track down and use the digital twin to figure out why some of those cold spots are happening, depending on the sensors that you've got running inside the building. Do we have the proper shading on our windows to know that we're protecting the building from extreme swings in heat and cold as they're coming along? Let's take that information and use it to make sure that we're putting energy and resources to the places that matter, cut off the parts of the building that don't matter because of not being utilized, and use that to reduce our energy consumption and build things forward.